In ancient times, people thought of planet Earth as the center of a universe they could not understand. Nightly, they gazed up at the sky, always with wonder, often in fear, and sometimes in worship. Nervously, they watched comets and meteors blaze their way across the heavens. The sun, they believed, was the great creator God of all there is, and the giver of life on Earth. People of many lands have worshipped the sun since at least 3,000 years ago, when the Egyptians chanted praise to their sun god, Ra.
Hail to you, Ra, who rises at dawn without failing. Your rays daily warm the land, yet they remain a mystery to all eyes. Fine gold does not match your splendor. In a brief day, you race a course of great distances. Then the day has passed when you go down. When you stir to rise at dawn, your brightness opens the eyes of the herds. When you set in the western mountain, they sleep as in the state of death.
When covered wagons were rolling westward across the American plains, the Sioux Indians danced and sang their praise to their sun god.
It was a bold step from worshiping the sun as a powerful god to measuring it through scientific eyes as a mammoth ball of energy that warms Earth with its heat and pushes back the night with its light. Circling their shepherd star, the sun, the planets also became the focus of scientific eyes, and like the sun, were looked upon as fallen gods. In the 1600s, the mathematician and astronomer Johann Kepler became the first to know the paths of the planets as they glide endlessly around the sun in their orbits. He found that a planet close to the sun moves faster than one more distant. Kepler was fascinated by this discovery and worked out a mathematical plan that assigned musical tones to each planet according to its distance from our local star, the sun. Here was the music of the spheres, imagined by the Greek philosophers of old. Today, Kepler's idea has been extended to the planets discovered since his time and turned into sound by a modern computer, although the planets do not actually play this mystical game of musical orbits. Kepler used the idea to show the order and harmony he supposed must exist in the universe. First, swift little Mercury, then Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto.
Of these wandering stars, as the ancients called the planets, one is very special. It is the third planet, alone among the planets, a water-covered globe, Earth, which would be better named Sea.
The planets were born out of a chaos of gas and dust. A giant disk wheeling about the infant sun 5 billion years ago. One, which came to be called Earth, began as a boiling, bubbling mass of molten rock. Over many ages, earthquakes ruptured its cooling crust, and volcanoes poured forth gases that became its atmosphere. And then the rains came, hissing and steaming off the hot surface rock, until eventually the new crust cooled enough to hold the rain in pools. The pools grew into ponds and lakes, which flowed as rivers into low-lying basins. The first oceans.
What were the early lives of the other planets like? What upheavals shaped their surfaces? Were they ever like Earth? Earth is a restless, changing planet. Beneath the crust, molten rock forces its way up from the mantle layer as lava. Long ago, lava flows also sculpted the surfaces of our moon, Mercury, Mars, and moons of the giant planets. Heat stored beneath a planet's crust changes the surface in another way, quakes. On Earth, about 20 enormous rafts of rock make up the crust. Heat pouring up from the mantle moves these rock plates around. Sometimes, as they grind against each other, Earth shivers in vibrations we call earthquakes. Ordinarily, we cannot hear earthquake waves, although we feel their effects. Scientists record earthquake sounds on a slow-moving tape of a tape recorder. When the tape is then speeded up several hundred times, we hear hours of earthquake vibrations in only a minute or so of tape time. These West Coast quakes were triggered by slipping and grinding of the San Andreas Fault in California and Mexico.
Of all the mysteries on our changing planet, the one that touches us most deeply is the creation of life. Our bodies contain atoms made billions of years ago in the fiery core of a supernova star. A drop of dew, a diamond, a butterfly, and all other life forms are made of the same matter as stars and planets. The earliest life forms we know of were bacteria and simple plant-like organisms that arose some 3.5 billion years ago. The dinosaurs are gone. Humans have replaced them as the dominant land animal. One important way human beings differ from all other living things is that we can ask questions. Questions about ourselves and questions about the other planets and the stars that lie invisibly beyond the known universe. We are finding answers by sending spacecraft across the eternally dark reaches of space.
9, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. Liftoff. We have a liftoff.
Our satellite probes, such as the Mariner spacecraft, which photographed Venus, Mercury, and Mars, send back to Earth coded information about the planets and the sun. Satellites called IMP told us about violent eruptions of hot gases in the sun's lower atmosphere. We learn about the planets, the sun, and other stars by studying their light and other energy. But light is only one small segment of the radiation stretched out along that wide energy band called the electromagnetic spectrum. We can think of this energy as waves, like electrical ripples.
In the gases of the sun or any other star, electrons jump around inside the atoms. As they do, they release energy. At the upper end of the electromagnetic spectrum is energy of short wavelength and very high frequency, gamma rays, X-rays, and ultraviolet rays. Next comes the band of energy we can see, with violet light at the high energy end, then down through blue, green, yellow, orange, and red at the low frequency end. Below the red, we can again no longer see the energy, but we feel the energy as heat when we move into the infrared. And at still lower frequencies and longer wavelengths is the energy of radio waves. Energy of the electromagnetic spectrum is sound, unless we translate that energy into sound. Imagine that we could hear the energy all along the spectrum, from high-energy gamma rays to low-energy radio waves and back again. Something interesting happens to a packet of energy of a certain frequency when the source of that energy packet speeds away from us or toward us. This is true of X-rays, light, radio waves, and sound waves. When the source speeds toward us, its waves get bunched up. We then hear it at a higher frequency than it actually has. When the energy source passes us and speeds away, its waves get stretched out. At such times, we hear the energy at a pitch lower than it actually has.
Astronomers use this effect, called the Doppler shift, to study how planets, stars, and distant galaxies move through space. With special instruments, such as radio telescopes and space satellites, they detect energy along the entire electromagnetic spectrum. With optical telescopes, they study light from the sun and other stars. But the sun also sends out radio waves. We can change these silent waves into sound and hear a flare or a sunspot or other solar activity as it begins quietly, builds to a peak, and then fades. Have you ever heard the sun? Energy from the sun drives storms in Earth's atmosphere and sets up wild electronic singing called whistlers.
A lightning stroke sends radio waves crashing out into Earth's magnetic field. The crash is made up of many frequencies. As they speed along the great loops of the magnetic field, the higher frequencies travel faster than the lower frequencies. The sudden crash has been stretched into a long electronic whistle. Flares on the sun cause gusts in the solar wind. They rattle Earth's magnetic field and produce a cosmic symphony. Part of it has been nicknamed the Dawn Chorus. Along with whistlers and the dawn chorus, Earth's magnetosphere roars like a lion, and nobody quite knows why.
The Viking spacecraft that landed on Mars in July 1976 took some of the mystery out of the red planet. There are no water-filled canals, there are no Martians. And in place of the lush vegetation once thought to grace the canal banks, Viking's television cameras and other instruments showed a rock-littered desert landscape smothered in iron oxide dust. The two Voyager spacecraft that flew by Jupiter in 1979 gave us spectacular close-up views of the planet King and 5 of his 14 moons. As Voyager 1 neared Jupiter, the tiny spacecraft crossed the planet's bow shock, a mammoth wall of charged particles bordering Jupiter's powerful magnetic field. The chirping sound is made by electrical charges dancing about near the edge of the shock. One of many Jupiter surprises was that the giant planet, like Earth, is alive with whistlers and with chirps of a dawn chorus.
With radio telescopes, astronomers tune in signals sent out by stars and by galaxies far beyond our own. Among such star sounds are some from special stars called pulsars. These are the rapidly rotating exposed cores of supernovas, stars that have blown off their outer shells of gas in catastrophic explosions. Pulsars hurl radio signals across the vast distances of the galaxy, much as the rotating beacon of a lighthouse sweeps its light beam around, one pulse for each rotation. We can hear this pulsar rotating 4 times a second. The younger a pulsar, the more rapidly it spins. Some rotate too fast to count by ear. We can hear a pulsar's rhythm in finer detail when we slow down the tape. Here is the pulsar Vela X at normal speed, about 10 times a second. And here, slowed down to 1/4 speed.
Of all the objects in the universe, black holes are among the most mysterious. Black holes are so dense that no energy can escape from them, not even light, so we have no way of detecting them directly. Astronomers suspect that black holes may lie at the center of many galaxies, such as this one known as M87. A clue to the black hole's existence are mysterious radio pulses coming from the heart of the galaxy. Perhaps the universe is a vast stage on which the mystery of creation is still being acted out. Do intelligent beings inhabit the dark depths of space, yearning as we yearn to hear a voice from afar? Many astronomers feel that advanced life abounds in the universe. At this very moment, a message written by Earthlings and beamed into space by the Arecibo radio telescope is crossing the universe at the speed of light.
If there are intelligent civilizations out there, perhaps one of them, one day, may hear that message. If they do, they will know they are not lonely witnesses to the wonders of the universe. And perhaps we ourselves someday may receive a message from other beings. A cosmic reading every bit as wondrous as the origin and evolution of life on planet Earth.